Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the solutions of 4 problems from the section Matrices and Determinants. And this is the third part of the 5 parts of the video devoted for matrices and determinants. Right. This question has appeared in the JEE Main exam held on 29 January 2025 in the first shift. The given question is, let capital M and lowercase m respectively be the maximum and minimum value of f of x is equal to the 3 by 3 determinant whose entries are functions of x, where x belongs to R. Then m power 4 capital minus lowercase m power 4 is equal to. Right. So we have to first of all write we are given 4 options. Right. Let's now discuss the solution of the problem in detail. We take fx, which is given as a 3 by 3 matrix whose entries are functions of x. So we want fx. Once we get fx, then we can talk about maximum and minimum values. So to evaluate this determinant, now I make 2 elementary row operations. R2 is R2 minus R1 and R3 is R3 minus R1. So then we'll get fx is equal to, the first row will remain as it is. Now after doing R2 minus R1, we'll get minus 1, 1, 0. R3 minus R1 will give you in the third row as minus 1, 0, 1. Now I again make another elementary row operation. R3 is R3 minus R2. So that this entry, that is the third row first column entry, is 0. So after the first row as it is, second row as it is, the third row becomes 0, minus 1, 1. Now expand the determinant. By expanding the determinant with the first column, 1 plus sine square x into 1 minus 0 plus 1 into delete that row and that column, and the minor is cos square x plus 4 sine 4x. Right. This is 1 plus, simplify, 1 plus sine square x plus cos square x plus 4 sine 4x. Sine square x plus cos square x is 1, 1 plus 1 is 2, 2 plus 4 sine 4x. It's now very simple to find the maximum value of this. The fx will take the maximum value when sine 4x is 1. When sine 4x takes the maximum value, that is plus 1. It takes minimum value when sine 4x takes the minimum value, namely minus 1. Therefore, capital M, f max is 2 plus 4 times 1, that is 6. Small m is equal to f min. The minimum value is 2 in 2 plus 4 times minus 1 minus 4. So 2 minus 4 is minus 2. Thus we got m power 4 minus small m power 4 is equal to 6 power 4 minus 2 to the power of 4. Now simplifying, we'll get 1280. It appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of this simple and straightforward question. Right. Right. This question has appeared in the JEE Main exam held on 28th January 2025 in the second shift. The given question is, let capital A is a 2 by 2 matrix whose first row is 1 by root 2 minus 2, second row is 0, 1, and capital P is the matrix. First row is cos theta minus sin theta, second row is sin theta cos theta, where theta is positive. If B is equal to P A P transpose and C is equal to P transpose B power 10 P, and the sum of the diagonal elements of C is given to be m by n, where m and n are relatively prime, then find the value of m plus n. Right. Let's now discuss. So we are given 4 options. These are the 4 options. So we'll now discuss the solution of the problem in detail. We look at P first of all. So that is this matrix. This matrix is a very famous matrix. It is a very well-known matrix. You might have got this matrix in several contexts of your intermediate study. And this is cos theta minus sin theta cos theta is called an orthogonal matrix. The meaning of that is any two distinct rows are orthogonal to each other. That means if you take the dot product of the first row with the second row, that is 0. And the length, the norm of each vector is 1. Cos square theta plus sin square theta is 1. Each vector, this is also true for columns. Such a matrix is called the orthogonal matrix. And the property is P transpose P is equal to P transpose is equal to identity. It means to say that the inverse of this orthogonal matrix is P transpose. Clearly, P is an orthogonal matrix, that is P transpose P is equal to P transpose is equal to I. Right. Now, given B is equal to P A P transpose. Now, in this, what you are seeing is B to the power of 10. So, to get B to the power of 10, first of all, let us try what happens to B square. So, B square will be P A P transpose square. What is P A P transpose? P A P transpose multiplied by P A P transpose. Now, look at this P transpose P. P transpose P is identity. P A I A P transpose. So, that's the A I A will be A square. P A square P transpose. If B is equal to P A P transpose, its square will be P A square P transpose. Working out like that, B cube will be P A cube P transpose, etc. It goes on like that. And ultimately, if you want B to the power of 10, it will be P A to the power of 10 into P transpose. Now, P transpose, now B power 10, we got it. Now, pre-multiply by P transpose and post-multiply by P on both sides. If you pre-multiply by P transpose B power 10, post-multiply by P multiplied by P will be on the right hand side also the same case. Now expand. So P transpose P transpose B to the power of 10 P is equal to, now P transpose P is identity, P transpose P is identity, and you will get a power 10. You will get a power 10. Now P transpose B to the power of 10 into P is given to be C. Thus C is this one, and P transpose B power 10 into P is A power 10. Therefore C is equal to A power 10. What is that we want? We want the sum of the diagonal elements of C. Now the sum of the diagonal elements of C is the same as sum of the diagonal elements of A power 10. A power 10. So first of all, what is A? A is given. A power 10, we have to multiply 10 times. Then take the diagonal elements of A power 10. And that will be the sum of the diagonal elements of C. We move to the next slide. Right, that's what we have. And let us take, we have seen sum of the diagonal elements of C is equal to the sum of the diagonal elements of A power 10. Therefore, we will attack A square, A cube, so on and so forth. We take A, right? In A, 1 by root 2 minus 2, 0, 1. Now, if you multiply A with A, then, first row multiplied by the first column will be 1 by root 2 whole square. And second row multiplied by the first column, it's always 0. And now the first row multiplied by the second column, something it comes, into second row multiplied by the second column, it will be always 1. It will be always 1. If you make a cube, then 1 by root 2 whole cube, something 0, 1. Like that, if you continue, then A power 10 will be equal to 1 by root 2 to the power of 10, something 0, 1. And the sum of the diagonal elements will be of A to the power of 10 is 1 by root 2 to the power of 10 plus 1. Thus the sum of the diagonal elements of C is equal to the sum of the diagonal elements of A to the power of 10. That will be 1 by root 2 to the power of 10 plus 1. 1 by root 2 to the power of 10 is 1 by 2 to the power of 5. That is 1 by 32 plus 1. That is 33 by 32. Let it be m by n. M is 33, n is 32. The GCD of m and n, there is a GCD of 33 and 32 consecutive integers. GCD is 1. GCD is 1. So what is that now we want? We want m plus n. So m plus n is 33 plus 32, that is equal to 65. Where is it? Option 4. The answer to this question is option 4. That is the detailed discussion of the solution of this problem. Right. This question has appeared in the JEE Main exam held on 24 January 2025 in the second shift. The given question is for sum A, B, let fx be this 3 by 3 determinant where x not equal to 0. Now, and it is given limit extends to 0 of this fx. So when you expand this determinant, you will get a function of x and take the limit extends to 0 of that function. If it is lambda plus mu a plus mu b, then what is the value of lambda plus nu whole square? We are given 4 options. Let's now discuss the solution of the problem. Take f of x, this 3 by 3 determinant, and limit extends to 0 of f of x will be limit extends to 0 of each entry. Yes, this is true. If you take fx and expand this determinant, you will get a function of x, then take the limit extends to 0 of that. It amounts to this one only. Now, this is equal to a, limit extends to 0 of a is a, plus limit extends to 0 of sin x by x is 1. This is 1, this is b. This is a, this is 1 plus 1, b. A, 1, b plus 1. To expand this one, we make two elementary row operations. By performing elementary row operations on a determinant, the value of the determinant is not going to change. Right. If you do that, you'll get the first row as it is. The second row is no. The third row remains the same. The first row now becomes first row minus third row, that is 1, 0, minus 1. And the second row is second row minus third row, that is 0, 1, minus 1. Third row remains same. Right. Now expand by the first row. So you will get this one. Expand this. You will get b plus 2 plus a. This is given to be lambda plus mu a plus mu b. Lambda is constant. Lambda is 2. Mu is the coefficient of a. The coefficient of a is 1. Nu is the coefficient of b, that is 1. And required to find the value of lambda plus mu plus nu whole square. That is 2 plus 1 whole square. That is 4 square, that is equal to 16 square. Where is my answer? Against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of this simple and straightforward question. Right. This is the question that has appeared in the JEE Main exam held on 24 January 2025 in the second shift. The given question is, if the system of equations x plus 2y minus 3z is equal to 2, 2x plus lambda y plus 5z is equal to 5, 14x plus 3y plus mu z is equal to 33. Let's call this system of equations as 1. And this system of equations has infinitely many solutions, then lambda plus mu is equal to. We are given 4 options. Right. Finding the infinitely many solutions, on infinitely many solutions, we have already got one question in this session only. Let's now discuss the solution of the problem in detail. The system of equations 1 have infinitely many solutions if delta, the determinant of the coefficient matrix, is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. Now, delta is the determinant of the coefficient matrix. Delta 1, it is same as the delta with the first column replaced by the values, that is 2, 5, 33. Delta 2, it is same as delta with the second column replaced by 2, 5, 3. Delta 3 is same as delta with the third column replaced by 2, 5, 33. Now look at them, and we want to find lambda plus mu, but that means we must get the values for lambda and mu. Look at them. If you take delta 2, in that mu is only present, and if you expand this determinant equate to 0, then you will get the value of mu straight. In delta 3 also you will see only lambda and expand it, and then you will get the lambda value. So for that reason, I will attack delta 2 and delta 3, and I will get the values of lambda and mu. I will take those values of lambda and mu, substitute in delta, and is it 0? In delta 1 we substitute, is it 0? So first I take delta 2. Right, this is the delta 2 I have taken. And now what's that I did? I did some elementary row operation. This is the elementary row operation. R2 is R2 minus 2R1. R3 is R3 minus 14R1. I did. So I got this one. And expand this one along the first column. You will get mu plus 42 minus 55 is equal to 0. And this will give you mu is equal to 13. Got it? Right. And now attack delta 3. So here also I have done some elementary row operations. So what are the elementary row operations I did? Same operation. R2 minus 2R1, R3 minus 14R1. I got to the first column 1, 0, 0 and expand delta 3 along the first column. Then I'll get 5 times lambda minus 4 plus 25 is equal to 0. Is equal to 0 is missing. I am sorry. Then you will get lambda is equal to minus 1. Lambda is equal to minus 1. Right. So now get into delta. In the place of lambda minus 1, in the place of mu 13, expand the determinant and you will get 0. Please check. And take the delta 1, substitute lambda is equal to minus 1, mu is equal to 13. Now expand the determinant, convince yourself that it is 0. You have to check. So these two checks, I will leave it to you. And we got the values of lambda and mu. We want lambda plus mu. Right. Lambda plus mu is equal to minus 1 plus 13, that is equal to 12. So where is my 12? Option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of this problem, and it is a very simple and straightforward question. All these 4 questions are very simple and straightforward questions. Right. I am sure that you have understood the solutions of these 4 problems. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.